Hey everybody. So today I thought I would make a video going over half of the problems for the 45, 45, 90 special right triangles. I know a lot of us are having a lot of trouble with this, and I'm going to end up spending an extra day on this, maybe even two, because I know that both special right triangles are giving people a hard time, and maybe the video I made wasn't as effective as I had hoped, and the people that are in class are still having issues as well. So I thought this would be worthwhile. So yeah, I'm going to do the odds, and if you have questions, please let me know. I'm more than happy to go over some of the evens with you as well, but I think for today's video, we'll be doing just the odds. So to remind everybody, the formula for the 45, 45, 90 degree triangle is going to be as such, and I'm just going to use X to represent the length of the leg in this case. So you'll notice that I'm drawing these arcs here. I'm not writing 45 and I'm not writing 45. I'm doing that because oftentimes these problems that occur in standardized testing involving special right triangles won't tell you it's a 45, 45, 90. They might just let you know it's an isosceles right triangle. And all isosceles right triangles have to be 45, 45, 90s. So they might write it like that. They might write it like this, and that would indicate it's a 45, 45, 90. Or they might do this. Why did I write that so small? They might say this is 45, but not tell you the other one. And any one of these three indicates it's a 45, 45, 90. Okay, so anyway, here's our formula. The length of the leg, or the two legs, are going to be the same. And then the hypotenuse, which is the side opposite the 90 degree angle, will be the length of the leg times radical 2. So knowing all of that, you can solve for missing sides of a 45, 45, 90 degree triangle, having been given only one side. Normally, you need two sides to find the missing side of a right triangle by use of Pythagorean theorem, or through the use of Pythagorean theorem. But with a 45, 45, 90, you can find two missing sides being given only one. Okay, so here, just like here, this doesn't tell us the second angle, but we know it's 45, 45, 90 because all the angles have to add up to 180 degrees within every triangle. And let's assign our variables. First thing I like to do is actually cross out these given variables they give us because I find them to be confusing. So this is going to be x, this is going to be x, and this is going to be x radical 2. So 8 is equal to x radical 2. So we're going to find x. We're going to solve this algebraically. So 8 is equal to x radical 2. And we're going to solve this, so we're going to divide both sides by radical 2 because we want to get x by itself. Okay, and that's going to cancel the radical 2's out. So we have x equals 8 over radical 2. Now there's a problem with that because we cannot have a radical in our denominator. That's going to make it an irrational number. Okay, so we're going to multiply the top and bottom by radical 2. We can do this because this is actually equal to 1. Any value above itself, or any value divided by itself will equal 1, right? Any non-zero value, rather. So this is actually just multiplying this by 1. It looks weird, but it's multiplying by 1 in order to make this number rational. So these radical 2's, any radical times itself will give you the number inside the radical. So this is going to become 2 on the bottom, just plain old 2, and then 8 radical 2. Okay, and we're almost done, but we can simplify this because 8 is divisible by 2. So 8 will become 4. So x will become 4 radical 2. And that's it. So this is going to be 4 radical 2. And this is 4 radical 2 because they're the same thing. Okay? So there's a lot going on there. Take a second to absorb that, right? Let's do the next one. Okay, so here, again, this is 45, 45, 90. So I'm going to cross out these variables. This is x, this is x, this is x radical 2. So they give us the leg. It's easier generally when they give us the leg. So that means this is the same, 2 radical 2. And this is x radical 2. So we're going to take this value, that's going to be our x, so 2 radical 2. And we still have to multiply by radical 2. So this is our x, that's our radical 2. Radical 2 times radical 2 would just give us 2. We still have the 2 on the outside. So this is 2, and then 2 times 2 is 4. So this is 4. Okay? Okay, next one. So again, I'm going to cross these out. So we have x, and this is x radical 2. So this is going to be the same as that. So 7 radical 2 over 2. And here we're going to multiply this by radical 2. So we're going to say 7 radical 2 over 2 times radical 2. Because this is our x value. This is our radical 2. Okay, these two radical 2's are going to become 2, because any radical times itself will become the number inside the radical. Think of it this way, like radical 5 times radical 5 is 5. Radical 7 times radical 7 is 7. Radical 9 million times radical 9 million is 9 million. So any radical times itself will give you the number inside the radical. It's a simple way of thinking about it. So this will be 7 times 2 on the top, because these become 2. We still have a 2 on the bottom. These 2's will cancel. It's 7. So our hypotenuse is 7. Okay? Here. Oh, light just went out here. So here we're going to cross out our variables we don't want. X, x, and this is x radical 2. So this is the leg, so that means this is the same. This is x radical 2, so x radical 2. So, okay, or x is radical 2, we're multiplied by radical 2. Radical 2 times radical 2 is 2, so it's just 2. Okay, bottom one here, so cross out our variables. X, x, and x radical 2. So this is 3 radical 6, and this is x radical 2. So x radical 2, our x is 3 radical 6, and this is radical 2. Now this is going to get a little interesting here. So radical 6 times radical 2 is radical 12. Are we done? No, we're not, because we can actually simplify this radical. So 3 and 4, and then 2 and 2. Okay. So we still have this 3 on the outside. So we have 3 on the outside. Then we have 2 times 2 times 3. These 2's will cancel, because they happen twice in the square root, and there's going to be a single 2 on the outside. So this 3 is still out there, so now it's times 2 on the outside, and we have a leftover 3 on the inside. And this becomes 6, because we're multiplying that. So 6 radical 3. This is 6 radical 3. That's a tricky one. Okay? Okay, let's look at the back side. So we have, to get rid of our variables here, so we have x, x, and x radical 2. Okay. Everybody say hi to Mr. Mikulicki. Hi, Mr. Mikulicki.
Hi.
You're on YouTube now. You're not famous. All right, so a whole, oh, actually, we get a fair amount of views. Nice job, guys. You're watching these videos, kind of, sort of. All right, so 5 radical 5 is going to be the other leg. And then we're going to multiply this by radical 2, because we have x radical 2. This is our x. So our x is 5 radical 5 times radical 2. Radical 5 times radical 2 is radical 10. And that cannot be simplified, so 5 radical 10. And that's our hypotenuse. Okay, let's get rid of these variables. Oh my goodness, what am I doing? That's 5. I apologize, guys. That's a 5. That's not a variable. This is the variable. Okay, so we have x, x, and x radical 2. So this is 5. This is x radical 2. So x radical 2. Look how easy this is now. So 5 is x radical 2. And that's it. 5 radical 2. Isn't that nice? I wish they were all like that, right? So 5, okay. So here, let's cross these out. This is 45, 45, 90. So we have x, x, and x radical 2. So this leg is 8. That means this other leg is 8. And x radical 2, so our x is 8. 8 radical 2. Oh, those two are easy peasy, huh? All right, last one. This one's not easy. All right, here we go. Oh, it's not the last, second to last one. So this is x, this is x radical 2. And I'm just using x as a variable. It could be any variable. You could do L for leg, N, whatever you want. It just represents the side of the leg, the length of the side. My goodness, brain's not functioning. All right, so these two are going to be the same. So 5 radical 6 over 6. This is going to be x radical 2. So x radical 2, our x is 5 radical 6 over 6 times radical 2. Radical 6 times radical 2 is radical 12. And we know that radical 12, we did that early. No, that was radical 12 was, radical 12 is here. Radical 12 was actually 2 radical 3, but let's just do it again, okay? So I'm going to simplify that radical 12. So radical 12 is going to be 3 and 4, 2 and 2. So it's 3, 2, 2. All right, so we're going to have 5 radical 2 2's and a 3. And then 6 on the bottom. All right, so we're going to cross out these 2's, put a 2 on the outside. So I'm actually going to write this over here. Sorry, guys, ran out of room. So the 2's going to be on the outside. So it'll be 5 times 2, radical 3 on the inside, then 6. So we're going to have 10 radical 3 over 6. And now we can simplify this because 10 and 6 are both divisible by 2, so this becomes 5, this becomes 3. So it'll be 5 radical 3 over 3, and that's it. That's a lot. Okay, that was a funky one. And that's our hypotenuse, 5 radical 3 over 3. And you can't simplify the 3's because this is a regular 3, this is a square root of 3. Okay, last one. We have our x, and our x radical 2. I'm going to go over there. So our leg is 5 radical 2. And we're going to multiply this by radical 2. So x, so we have a little space here. X radical 2, so our x is 5 radical 2 times radical 2. And this will become 2, so 5 times 2, and that's 10. And that's it. All right, hopefully that was helpful, guys. I'll be doing another video on the 30, 60, 90s, which I hope helps you guys out. I'll see you soon. Bye-bye.